Chapter 2,
The check-in.
You want to do your best, you want to do well, so you watch this video
Of me.
I'm Mr. B, I teach math.
I have cat.
I am here
To help you.
CHPTER 2. Chapter 2, CHECKIN. Check-in 2. Hey, it's me, Mr. Barbera. I think I have a little bit of a cold, so sorry if I'm a little low energy and my voice doesn't sound quite right. I'm going to keep a side piece of paper here. As I mentioned in class, the practice test isn't formatted as cleanly as I would have liked, so the real test is going to be a little easier to show your work. So sorry if you had to cramp your work in here a little bit. For standard 1, it says use a number line or plus and minus tiles to show the following. I'm going to go ahead and use the plus and minus tiles. I saw most students doing that in class. If you like a number line, that's fine too. If I'm doing plus or minus tiles for -3 plus 7, I'm going to make 3 negatives. That's my -3. And I'm going to do 7 positives. And then I need to remember to make my 0 pairs. So every time I have a positive and a negative, they're going to cancel out and make 0. So in this case, I have 3 0 pairs. And whatever I'm left behind with, that's going to be my solution. So my answer here is going to be +4. And don't forget to write your answer too on the test. But there'll be a box for that. The next one, -5 plus -6. -5 would be 5 negatives. And -6 is just going to be 6 more negatives. So if we look at this one, we don't actually have any more, we don't have any 0 pairs, so we're just going to count them up. So 5 plus 6 would be 11, but they're all negative. So my answer is -11. So we're adding the 2 negatives, it just gets more negative. Next one, 3 numbers, the same idea applies. I'll leave a little space here. So 6 negatives, 1, 2, 3, 4, 5, 6. 17 positives, sorry about that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 9 negatives here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. You can also, if you want to, you can put all the negatives together first and combine those and then put the positives. That's a cool strategy. So my 0 pairs, I have 6 from the -6. I should have another 9 from the -9. And these ones I have to kind of do here. I'm going to kind of do like this. Just make sure I had the right amount. 1, 2, 3, 4, 5, 6, 7, 8, 9. I did. And I'm left with 2 left over. And those are +2, so my solution is +2. And then -3 and -11 is just -3. -11. 7, 8, 9, 10, 11. Sorry if you could just hear me whispering numbers to myself. And I'm just going to count them all up, and then be 14 negatives. Woo, standard 1. All right, standard 2, you're not asked to draw the tiles of the number line, but I do think thinking about them helps me. So if I'm thinking about 23 and 2, I think about how many 0 pairs am I going to make? Well, 2 is my smaller absolute value. It's less than 23. We're just ignoring the signs for a second. So these 2 positives would cancel out with 2 of the negatives. So I can actually kind of think about it as like 23, and I'm taking away those 2 0 pairs, and I'd have 21 left, but it's 21 what? Well, they're negatives, so this would be -21. Part B, let's use a similar strategy here. I have 7 negatives, and then the positives I'm going to add up. I think that's easier here. So if I have -7 plus 14 plus 9 is 23. How many 0 pairs am I going to make? Well, I'm going to be able to make 7. That's my smaller absolute value. So I can think about, okay, when I take away the 7 from my 0 pairs, I'm left with 16 positives. Next one's just 2 positives added up. So 64 plus 18. 4 plus 8 is 12. Carry the 1. 8. Oh, I started to multiply. That's funny. 6 plus 1 is 7. Plus 1 is 8. So that's 82. And then the last one, again, I would combine the negatives first and then combine them with the positives. But if you use a different strategy, that's okay too. So I think of this as 17 plus -27. How many 0 pairs am I going to make? Well, 17. So when I do that, I could subtract to find out that there's going to be 10 negatives left over. So it's negative 10. Standard 3, we're adding and subtracting fractions. When we add or subtract fractions, we're going to need to find a common denominator. So, and on the real test, I left your room below because I'm going to show you how I like to show my work. I would go down. So I'm going to use a common denominator. At lowest common denominator too will be, is it 52? 3 times 14 is 30. No, sorry, 42. To make 14 into 42, we multiply by 3. And to make 3 into 42, we multiply by 14. So we do the same to the top. 5 times 3 is 15. 3 times 14 is 42. 2 times 14 is 28. And the denominator is 42. Now we're subtracting, but we're taking away more than what we have. So we're going to end up with a negative answer. And when I take away 28 from 15, I'm going to end up with negative 13. And it's still over 42, so keep that denominator there. All right, moving on to the next one. 4 over 9 minus 2 over 5. Common denominator here is going to be 45. So I multiply 4/9 by 5 over 5. I multiply 2/5 by 9 over 9. I'm going to get 20 over 45 minus 18 over 45. And now just 20 minus 18 is going to be 2 over 45. And the last one, same thing, looking for a common denominator. My common denominator here is going to be 28. Multiply the top and the bottom over here by 4. Top and bottom over here by 7. And I'm going to get 20 over 28 plus 7 over 28. And then that would just add across the top. 27, keep the denominator, 27 over 28. Woo! All right, standard 4. We're multiplying now. So my first one here, I have 5 times negative 4. So that'd be 5 groups of negative 4. I could think about it in tiles. So I could do negative 4, but then 5 times. And if I count these up, I'm actually going to have negative 20. You can also think about it as there's 5 times 4 is 20, and they're groups of negatives. So you could just know it's negative without drawing the tiles. Some fractions here. Multiplying fractions, we just multiply across the top and across the bottom. So 5/11 times 3/5. 5 times 3 is 15. 11 times 5 is 55. And I can actually divide these both by 5 over 5 to get 3 over 11. Try to simplify on the test. If you make a mistake, I won't mark you wrong. But I do like to see you try. Next one has mixed numbers here. So if I have a mixed number and I want to multiply it, you can draw a generic rectangle, which we did a little bit in class. But you can also change to improper fractions. I'm going to go ahead and use the proper fractions here. So 4 times 3 is 12, plus 1 is 13 over 4. 8 times 6 is 48, plus 1 is 49 over 8. This is a little ugly to multiply here, but 13 times 49. 9 times 3 is 27. Carry the 2. 9 times 1 is 9, plus 2 is 11. Bring down a 0 because I'm in the 40s. I'm in the 10s, I mean. 4 times 3 is 12. I have a 1 now up here. 4 times 1 is 4, plus 1 is 5. And I add them all up. And I get 637. And 4 times 8 is 32. We're going to go ahead and just leave it like that for now. And this one here says use an area model. Just a reminder of what an area model is. It's a rectangle. It's also, we called it a unit rectangle, I think is what we called it. You're going to show one fraction in one direction, the other fraction in the other direction, and then where they're double shaded is where our solution is. So 3/5, I cut it into fifths. I shade 3 of them. 1, 2, 3. There's 3/5. On the other side, I'm going to do 1/3. So I'm going to cut it into thirds. Just a little better. And then I think I have purple over here. I'm going to color one of these. And the solution here is the double shaded part, which is 3, out of the total number, which is 15. And 3 actually does go into both of these. So if we divide this, we get 1/5. All right, last one here. We got to do a little long division. Remember, the top number goes on the inside of the house. So if it's 1/6, I go 1 on the inside, 6 on the out. 6 does not go into 1, so I put a decimal. Now it becomes 10/10. 6 goes into 10 one time. 1 times 6, 6. Subtract, I had 4 left over. Now I'm in the hundredths place, so I get to bring down 1 0 for free. 6 goes into 46 times. 6 times 6 is 36. And I have 4 left over. Now, since I had 4 before left over, and I have 4 again, what's going to happen is I'm going to repeat this pattern forever, and I'm always going to have that 6 repeating. So it's 0.16, and just the 6 repeats, not the 1, because I'm not getting a 1 back in my remainder. I'm only getting a 4 in my remainder. Next up is 2/9. 2 goes inside, 9 on the out. Decimal point, bring down to 0, because 9 does not go into 2. 9 goes into 20, though, twice. 2 times 9 is 18. I'm left with 2 left over. And again, same thing. I'm going to end up with this 2 over and over. So it's going to be a 0.2 repeater. You might have remembered this pattern that anything over 9, if it's like 4 over 9, it's 0.4 repeater. But you still need to show the long division because that's what the standard is. 7/5. 7 goes on the inside. Let me scroll this up a little bit. 7, 5 over here. 5 does go into 7 a whole time, so once. 2 left over. 5 does not go into 2, so now I put my decimal point, bring down to 0. But then 5 goes into 20 an even number of times, so 4. Nothing left over, so just 1.4. And the decimals here, we just say our decimals with place values, so 0.33. The last number is in the hundredths place, so this would be 33 hundredths. 576, the last number is in the thousands, so this would be 576 thousandths. And you could divide it both by 2 and simplify, but I'm going to leave it like that for now. And then these ones, we just need to know the pattern. So if there's 1 digit repeating, then it's the number that repeats over a 9. But remember, if it was like a 2-digit repeater, like 0.27 repeater, that would be 27 over 99. Or if it was a 3-digit repeater, like 0.07 repeater, that would be 107 over 999. All right, that's your practice test video. Good luck.